हेलो स्टूडेंट्स। तो आज हम डिस्कस कर रहे हैं कंटिन्यूटी एंड डिफरेंशिएबिलिटी एक्सरसाइज 5.1। फर्स्ट क्वेश्चन इज प्रूव दैट द फंक्शन f(x) is equals to 5x minus 3 is continuous at x equals to 0, x equals to minus 3 and at x equals to 5. First of all, for continuity we must know, for continuity limit x approaches a, continuity at a, you can say here at a of the function, limit of the function at a must exists and it must be equals to function's value at a. Means limit x approaches a must be equals to the function की value f equals to a पे, f a पे है ना, x equals to a पे ये होना चाहिए कंटिन्यूटी के लिए। ओके, सो फर्स्ट क्वेश्चन हम देखते हैं। फर्स्ट क्वेश्चन है हमारे पास f of x is equals to 5x minus 3। कहाँ चेक करना है हमें? x equals to 0 पे। लिमिट x approaching 0 of the function is 5x minus 3, it will be 5 into 0 minus 3, that is minus 3, and function's value at 0 f0। तो क्या करना है आपने? x की जगह पे अगर 0 है तो इधर भी x की जगह पे आपने क्या रखना है? 0 ही रखना है। तो x की जगह पे हम 0 रखेंगे -3, तो ये भी -3 आ जाएगा। तो क्या हुआ कि लिमिट x अप्रोचिंग 0 ऑफ f(x) और फंक्शन की वैल्यू 0 पे, दोनों ही -3 और -3 दोनों ही इक्वल आ गए। हेंस f(x) equals to 5x minus 3 is continuous at x equals to 0. Okay, now we have to check continuity at x equals to -3, at x equals to -3. For this, again limit x approaching -3 of the function 5x minus 3 will be equals to 5 into -3 minus 3. It will come out -15 minus 3, that is -18, and function's value at x equals to -3. तो अगर x की वैल्यू हमने यहाँ -3 रखा है तो यहाँ भी हम x की वैल्यू क्या रखेंगे? -3 रखेंगे। तो 5x की जगह पे -3 ये भी -18 ही आएगा। सो we have here limit x approaching -3 of the function f(x) and function's value at -3 is equal, that is -18. Hence f of x is equals to 5x minus 3 is continuous at x equals to -3. Now we have to check at x equals to 5. So limit x approaching 5 of the function f(x) of 5x minus 3 which equals to 5 into 5 minus 3। x की जगह पे आपने 5 रखना है ना, x की जगह पे आपने 5 अप्रोच करवाना है। तो it will come out 25 minus 3, that is 22, and function's value at 5, so 5 into x की जगह पे आपने 5 रखना है, तो 5 minus 3, again it will come out 22. So limit at x approaching 5 of the function and function's value at 5 both are equal, that is 22. Hence f of x is continuous at x equals to 5. Now question number 2. Examine the continuity of the function. Function is f(x) equals to 2x square minus 1 at x equals to 3. Okay. So first of all we will find limit कहाँ पे? At x equals to 3, x approaching 3 of the function that is 2x square minus 1. when you will approach 3 to x, so it will be 3 square minus 1 will come out 2 into 9 minus 1, that is 18 minus 1, 17. Now function's value at 3, so you have to simply put x equals to 3 here. Okay, so 2 into 3 square minus 1, it will come out 2 into 9 minus 1, that is equals to 17. So again here limit x approaching 3 of the given function f of x is equals to function's value at 3, that is equals to 17. Hence you can write the function is continuous at x equals to 3. Okay, next is examine the following functions for continuity. Again continuity you have to check. Function is f of x is equals to x minus 5. So you have to check the continuity. First of all, let any real number c belongs to its domain. Okay, and domain belongs to its domain. So limit at x approaching c of the function x plus c, it will x plus 5, sorry, it will come out c plus 5. Now, function's value at c, will be again c plus 5. Simply x की जगह पे आपने c रखना है, c plus 5. So from here limit x approaching c of the function is equals to function's value at c. Hence you can say f of x is continuous. Okay, f of x is continuous. Now question part B is f of x is equals to given to us 1 over x minus 5, and x is not equals to 5 means its domain of the function is x belongs to real number and x is not equals to 5, or simply you can write domain is real number minus set containing 5, you can write. Okay, so what we will do, first of all we will let c belongs to the domain, okay, domain of the given function. So limit at x approaching c of fx, and fx is here, limit x approaching c, fx is 1 over x minus 5. So simply you have to put c here, so it will come out 1 over c minus 5. And now function's value at c, so f of c, it will be c minus 5, 1 over c minus 5. So from here we can see easily limit x approaching c of fx is equals to f of c. Therefore the given function is continuous. Hence you can write hence f of x equals to 1 over x minus 5, where x is not equals to 5 is continuous function, is continuous. Okay, so now part C. So part C is f of x is equals to x square minus 25 over x plus 5, and x is not equals to minus 5. So from here you can simply write this one, x square minus 5 square, 25 can be written as 5 square x plus 5, and we know that a formula a square minus b square, it can be written as a minus b and a plus b. So, and x is not equals to minus 5, so x plus 5 cannot be equals to 0, so we can cancel out x plus 5 as a factor. So finally we are left with fx is equals to x minus 5, and domain of this function is real number minus set containing minus 5. You have to keep in. Okay, so let C be any real number belongs to its domain. So limit x approaching C of fx, and fx is here x minus 5 now. So x minus 5, it will come out C minus 5. And function's value at C, फंक्शन की वैल्यू C पे, तो C minus 5. तो ये भी C minus 5 आ गया. ठीक है, तो दोनों इक्वल आ गए. लिमिट x approaching C of fx and function's value at C, both are equal, that is C minus 5. Hence f of x is continuous. Okay, now next part D is f of x is equals to mod of x minus 5. Okay, so its domain will be real number, all real number. Okay, modulus functions, its domain will be all real number. So you can simply redefine this function. Okay, redefining this function will be redefined as f of x is equals to minus of x minus 5 when x is less than 5, and plus of x minus 5 when x is greater than equal to. Okay, simply you can see from here. तो फर्स्ट ऑफ ऑल जहां भी फंक्शन का बिहेवियर चेंज होता है हम वहां पे चेक करते हैं. ठीक है, तो हम चेक कर लेते हैं कहां पे, एट 5. ठीक है, तो वी विल चेक कंटिन्यूटी एट 5. फर्स्ट ऑफ ऑल लेफ्ट हैंड लिमिट मीन्स लिमिट x approaching 5 minus पे चेक कर लेते हैं. 5 minus, और 5 minus फंक्शन इज 5 से छोटे नंबर के लिए है ना, 5 से छोटे नंबर के लिए 5 माइनस का मतलब है 5 से छोटा नंबर, इसके लिए फंक्शन क्या है, minus x minus 5. when you will approach 5 here, it will come out 5 minus 5, it will approach 0. Similarly, right hand limit x approaching 5 plus 5 से ज्यादा के लिए फंक्शन की वैल्यू क्या है, x minus 5. x की जगह पे अगेन आपको 5 पुट करना है, तो 5 minus 5, it will come out 0. and now function's value at 5, so at 5 you have to take x minus 5, so again it will be 5 minus 5, comes to be 0. So from here LHL is equals to RHL is equals to function's value at 5, all are equal to 0. Hence you can say f of x is equals to mod of x minus 5 is continuous. Okay, continuous. Now next question is question number 4. Question number 4 is prove that fx equals to x raised to the power n is continuous at x equals to n. Okay, so first of all we will evaluate limit at x approaching n. Okay, you have to check continuity at x equals to n, so you have to check limit at x approaches n of the function is x raised to the power n. When you will approach x to the n, it will come out n raised to the power n. Now function's value at x equals to n. Okay, function's value at x equals to n. When you will put n here, so it will be n here also, so it will come out n raised to the power n, and both are equal. Limit x approaches n of the function fx is equals to function's value at x equals to n, both are same, n raised to the power n. Hence f of x is continuous. Hence f of x is continuous at x equals to n. Next is the function f defined by fx equals to x when x is less than equals to 1, and 5 if x is greater than equals to 1, is continuous at x equals to 0, at x equals to 1, and at x equals to 2. Okay, simply with the help of graph you can see also, and हम इसको प्रूव भी कर लेंगे. ठीक है, फर्स्ट ऑफ ऑल हम चेक करते हैं एट x इक्वल्स टू 0 पे. ठीक है, एट x इक्वल्स टू 0 के लिए फंक्शन की